So let's look at two formulas. There are two formulas which you need to remember in sets, right? There are other formulas as well, but these are two important formulas which you need to remember. If you look at the first formula, there are only two sets over here, A and B, right? And what they say is that what we learned in cardinal number is that cardinal number is nothing but the number of elements in a particular set, right? So for example, the number of elements in the universal set are 9 if you look at it. Similarly, the number of elements in A is 1, 2, 3, 4, 5. Here it is 4 and n of C is 6, right? That is what we learned. So with respect to the cardinal number of this particular combination, we have this particular formula. What it says is that n of A union B, remember, note this one. You have a union B over here is equal to n of A, means the cardinal number of set A plus the cardinal number of set B minus the cardinal number of A intersection B. That's the formula you need to remember. I'm going to prove it with this particular example. That's why I noted this example. Okay. And when there are three sets, A, B and C, the formula is this one. N of A union B union C is equal to the combination of cardinal number of A plus cardinal number of B plus cardinal number of C minus the intersection of in pairs A versus B, B versus C and A versus C. And you need to add the intersection of all the three sets and find the cardinal number. So that's the formula, you need to remember that. Now let's look at the first one. Okay, they say that let's find n of A union B. So for finding the cardinal number of n of A union B, you need to find A union B, right? What is A union B from here? Can you tell me? Okay, so it is 1, 2, 3, 4, 5, 6. There is no 7, so you have this one, right? A union B, when you combine these two, you get this one. So what is the cardinal number of this one? The cardinal number of n A union B is equal to 8. The number of elements in that one. Okay, good. Now let's find out n of A. So this is left hand side. This is actually left hand side. Right, this is what you got, 8 over here. N of A union B is 8. Now on the right side we have to prove that this plus this minus this should give you 8. Then this holds good. Okay, so n of A is how many elements? 5. N of B is 4. Right, now let's find out A intersection B. Before we find out the cardinal number, you need to find out A intersection B. What is A intersection B? Look at it. It's only 8. There is only one element which is common. It is present in A and B. That's why we have 1. So therefore, the cardinal number of A intersection B is equal to 8. Now look at it. Can you plug these values over here? What did you get? N of A is equal to 5 plus what is N of B? It is 4. And what is N of A intersection B? It is 1. What do you get? 8. Look at it. 8 is equal to 8. So I have proved it that this formula exists. Okay. So remember this particular formula. Okay. So that it helps you to solve problems. Now let's move forward to prove the second formula. Okay, let's prove the second formula over here for cardinal numbers. So, okay, let me write. Okay, let's go step by step. What is LHS? LHS is n of A union B of union C. So first you need to find A union B union C. What should you get when you do that? What should you get when you do A union B union C? So it should include all the elements from all the three sets. It should be present in either of them. So it is nothing but it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the n of A union B union C is 9, right? Remember that value. Now to just save space, right, I need to rub this. That was your LHS over there. Now n of A, you know n of A. N of A is 5. N of B is 4. N of C is 6. So let's leave those values there. Now let's come to this one. N of A intersection B. What do you have? A intersection B. What did we get last time? We got it as 7. I'm sorry, 8. 8 is the only common element between these two. What is the next one? So this becomes N of A intersection B is equal to 1. Now next one is B union C. Let's see what are the common elements between B and C. B and C. What are the common elements? You have a 3 common. Yes, that's it. You have a 3 common. That's it. So N of B intersection C is again 1. What is A intersection C? What are the common elements between A and C? Look at it. 2. I have a 2 common. I have a 4 common. I have a, there is nothing else, right? 2 and 4, 2 and 4. There is nothing else common. So N of A intersection C is 2. Now the last one, A intersection B intersection C. Okay, so you already have a B intersection C over here. Look at it. It's 3. Can I pitch it against A and find out? Look at it. Do you have anything common between B intersection C and A? Do you have anything common? There is nothing. It's a null set over here. So therefore N of A intersection B intersection C is 0. Okay, now put the values. Now put the values whatever you have got on the right side. You have got this one as 5. 5 plus 4 plus 6 minus 1 minus 1 minus 2 and plus 0. Add all of them. 5 plus 4 is 9. 9 plus 6 is 15. 15 minus 4 is 11. 11. How did we get 11 over here? 5 plus 4, 9. 9 plus 6 is 15. 14, 13, minus 2, 11. So we have done something wrong somewhere. A union B union, A intersection B intersection C. B intersection C is 3. Against this one, you get only 1. Yeah, you don't get anything. A intersection B, you get only 3, only 8. That is correct. B intersection C, oh, here. B intersection C, actually it is. B intersection C is 1 and 3. If you look at it, we missed out that. We missed out that, yeah. This is where we have gone wrong. So this is 1, 3. Look at it, right? Now let's do once more this one. So this becomes 2. This becomes 2. Now A intersection C. A intersection C, you have a 2. You have a 4. 6, 8, 9. You have another one 6 here. That's what we missed out. So this is 6. So this becomes 3. This becomes 3. So plug the values back. You're going to get it. I made a mistake over here. So okay. So we got A intersection B as 1 and this one as 2 and this one as 3 plus 0. Look at it. Now add it. 5 plus 4 is 9. 9 plus 6 is 15. 15 minus 1 is 14. 14 minus 2 is 12. 12 minus 3 is 9, which is equal to 9 what we have got over here. So understood? So remember these two formulas. These two formulas will help you to solve a lot of problems. Okay, let me rub this one completely and remember these two formulas. They are very easy to remember if you want to put it in your mind map. Okay, simple. What you need to do is that remember on the left side it's always union. A union B. When you have a union B over here, on the right side it will be all intersections between those two sets. And you are going to anyhow add these. The individual elements, individual cardinal number, the cardinal number of the sets. Remember, you are going to add them. So here again, n of A intersection B intersection C is equal to n of A plus n of B plus n of C, and you're doing the same thing. That's why I put it in three different lines over here. You are basically negating the intersections and adding the intersection over here, the last one here. Don't forget this. Okay, these are the two formulas which are very important for cardinal numbers and sets when you're doing problems. Okay.